people's これ female male あるじゃんね。population balance とかいうの。まあ this is very good balance. But to the なんか in Japan's present condition is about まあ something like this. Something like this. So the 100 とか80とか60 the elderly people become this rate, population rate become increasing now. So that is a very serious problem. So population balance is not good. So therefore that becomes a very serious problem. Okay? まあ developed country is the similar problem we have. Why? Developed countries have this kind of serious problem presently. Why it is?
Because of advanced medicines.
Advanced medicines か。Advanced medicines ね。Advanced medicines. Advanced まあ medicine and other technologies and engineering technology including. So to keep the living lifelong time become prolonged by developed advanced technologies, advanced medicines. So yes, that is one important answer. And also it makes why this is problem? Why this is problem? Because what is the problem? The people become larger, increasing these elderly population become larger, become increased. Why this is a problem?
Because if there's too much old people, the government has to spend a lot of money to take care of them.
そうだからコストプロブレムね、mainly the money cost problem and also the money cost and labor cost. Of course, how to support them? How to support them? It takes much money. It takes workload. Of course. So therefore, that is a problem. In any time, in any way, the cost is a very serious problem. How to support this cost? How to make this cost? まあ developing country and the present about 20から大体60とか50とか This is a working populations. Working populations should support them. The working population should support them. But these people's number of these peoples become decreasing. So therefore it is difficult to support these working people cannot support the elderly people. That is a serious problem. So therefore the cost reduction is very important issue. But the medicines become advancing, of course. So the new drugs, new surgical operation technology become increased. Yes, that is okay to make the people's life longer and longer. Of course, and not only the lifetime longer, but the healthy people should be prolonged. This is also because the weakened people to prevent go to bed, lame. The elderly people should be the healthy conditions. But the lifetime is also prolonged. So therefore the cost is not so become decreased. So therefore the engineering technology should be used to reduce the money cost, labor cost. That is a very serious problem. And also the engineering technology should contribute to reduce these costs. Ah, 何でもコストなんですよ、コスト。コスト is a serious problem. はい。という話です。OK? はい。です。これ。はい。で、today's part is これだ。これね。リハビリテーション、まあメディカル、ウェルフェアでリハビリテーションなんだけど、まあウェルフェアってサポーティングで、リハビリテーションは to recover ね、damaged people とか injured people の recover。How to recover their usual functions, usual abilities。まあ、it is similar to the welfare assisted technologies, almost similar。Today's content is divided into two parts. The first one is lower extremity. これですね。Some usual method and some engineering supporting technology shown here. And our laboratory's activities looks like this. From this part, the second part is upper extremity. これ usual method. And engineering technology, robotics technology to support and assist and to make rehabilitation to effectively like this. Is shown here. And our laboratory's approach looks like this here. っていうのがなんだけど。Okay, that is briefly at a glance of this today's conference ね。で、lower limb, upper limb. Which do you like better? Which do you like to know more? Lower walking とか or operation, arm operation. Which you like? Lower なのね。はい、じゃあ、to start from here. ここに書いてあるのは何ですかと言ったら、これは、ジェネラルリハビリテーションテクノロジーの話ね。それから、ストローク。Maybe you know the stroke. Head is damaged. Some part of the brain damaged by the blood or the high blood pressure or something. And so therefore, some part of the human body has been paralyzed, cannot move as you like. So, in many cases, the right side or left side is paralyzed. So to recover it, how to recover it is very important. So therefore, some robotics engineering technology is used. これですね、robot for the lower limb rehabilitation. The stroke patient, paralyzed legs should be recovered. So therefore, or accident, after the accident, the muscle become weakened. So therefore, to recover it in the usual function, normal function, the rehabilitation is necessary. So the firstly, muscle strength exercise should be done. ね、ウォールバーとかスタンディングアップとかレベルウォーキングとかレベルウォーキングそれからステアクライムステッピングエクササイズ should be done. And the prescribing, the making the lower extremity orthosis is provided. The knee, ankle, foot orthosis, knee, ankle processes. And this is ankle, only ankle. Ankle, foot processes, short leg brace is there to keep ankle joint. To keep ankle joint is very important to usual work. Because some people cannot control the ankle joint, that is very difficult to, this makes the difficult to walk usually. Because we should swing up the pen, swinging up the lower legs, this ankle should be, the two top should be raised. So, but if it cannot control, it is to scratches on the ground, so therefore it cannot walk usually. The raising up is very important. So therefore, to keep the ankle joint, this part of this kind of supporting tool is also provided. Gait. You know the word gait? Gait. Walk gait, ne? Walking gait. Gait is the どうするなんかこういう時からboth foot is grounded and the gait ってでbackward leg should be raised and swing to here and the grounding. だスイングフェーズこれはグラウンディングフェーズスインギングフェーズ and グラウンディングフェーズ some phases is there. The gait means the walking operations, walking movement is separated into 3 or 4 phases. Standing, one leg standing, and swinging, and 2 leg standing, and the 1 leg standing and swinging, and so on. This kind of some phase is repeatedly, that is a gait, one gait. So the gait rehabilitation is necessary. Firstly, the treadmill, you know the treadmill. Okay? Some treadmill is only one belt is here, but some treadmill is separatedly. The left side and right side is separated. This type is separated. これは more than about 15 years ago, the Hitachi Corporation developed this walking rehabilitation system. The 2 belts is here, and this is bar to support the body, and this is a display to show this looks like some pet dog is here, and pet dog leading his walking, her walking. This looks like this. And this type is only supported by her arms. Her arm support is the upper body, but some weakened legs, it is very high work load for the lower limb. So therefore, the body weight is supported by these things. It looks like this. The body weight supported treadmill is also developed. So it looks like this. This sling, this belt is supporting the upper body. This type looks like this, and some type is the rail is given on the seal, and this robot is moved along the seal and supporting according to her walking. And the treadmill-based gait training robot. Firstly, this is this UC Irvine Robotics laboratory developed this kind of robot. The pelvis is supported by this arm, and this gait motion is supported by the exoskeleton model, exoskeleton supporting system. これちょっと見てみますか。でもこのエグゾスケルトンはここに fixed to this outside frame ですね。この fixed to the outside frame に this part is connected in this case でした。これがまあ about 2007 yearアートフールというのはアンビシオスアシストロボットツール for human rehabilitation でリニアアクチュエーターというサポートペルビスというのは、まあ、リニアアクチュエーターというサポートペルビスというのは this here であとはこれは、コマーシャルプロダクトでロコヘルプとかペダコとか言われてるやつが This is on the treadmill this tool is put on here and this boot is moving along this trajectory. This looks like the walking trajectory. The neurological rehabilitation with gait trainer っていうので was developed to relieve therapist of the labor intensive task of guiding the patient leg. So usually the treadmill training, this trainer is supporting his leg and move, looks like this, for to understand, to recover the gait movement of the legs. Okay? So, but this therapist is very, very high workload to do this. So therefore, in place of this therapist, this mechanical movement tool is attached on the treadmill. ちょっと、なんか見ると、ここにありますね、これ。まあ、ハーネスのセットアップとか見てもしょうがないけど。こういうセットアップは very, very important, but it takes much time to do this. これスキーブーツみたいなんですね。looks like a skiing boots. で、ここにアタッチして、で、釣り上げて、で、ウェイトコンペンセーションをして、で、こうやっていきましょう。というやつでした。似たようなシミラープロダクトは、オコマっていうスイッツァーランドカンパニーのロコマットっていうやつがあって、ロコマットプロとかロコマットなんかがあるんですけど、まあいいや、こういうゲートリハビリテーション、ウェイトコンペンセーションとゲートリハビリテーションシステムです。まあ言ったように、これモトニカっていう会社、モトニカは USA カンパニーなんだけど、レオアンビュレーターというやつがあります。これはまあ同じようにここに、エグゼスケルトンみたいなアシストシステム、アシストロボット is attached to the side of the patient, and then the walking gait motion is produced by, assisted by this robot ですね。あとこれがちょっと面白いのは It is a little bit different method. Anti-gravity treadmill っていうのは How to do this anti-gravity これはここがエアバッグなんですね。エアバッグ。これ NASA technology is used. And the air bag is supporting this pelvis. And this air, high pressure air supporting this weight, her weight. So therefore, it can be used. ちょっとアンティグラビティトレーニング、こいつを見てみましょう。これは not only patient, but also the running, the jogging, running support is also made. フィットネスジムとかにもこういうのあります。
Chamber that we put you down into, it kind of inflates the compartment that lifts you up off the treadmill. As you start to take body weight off of you, you'll not only feel a little bit more control, but you'll definitely start to feel yourself get lighter.
That button makes the how much percentage of the self weight should be compensated. It can be decided, can be ordered on this way. ってやつですね。というようなアンティグラビティトレッドミルというのもあります。あとはこれは何？メディカ、これもジャーマンカンパニーのリーダー、ライト。これペダルがついてて、ペダルの、this gate movement is here。はい。あと、トヨタカンパニー is also produce this kind of the gate motion training system。ちょっとこれ、見てますか？
本当にギリギリの助け方です。これはものすごくデリケートです。で、それをできるのはロボットの、知恵というか、スピードの速さ、反応の速さ、そして一番重要なところを助けるという、理屈ですね。これが実際の結果として普段のトレーニングよりも約 1.6 倍速く良くなるということが今分かってきていて、でそうすると、長い入院期間を短くもできるかもしれないし、時間切れで歩けなかった人が歩けるようになるかもしれない、このような、期待が持たれています。
はい、はいです。はい、です。あと、ああいうスタンド、fixed on the ground とか fixed on the field じゃなくて、これはThis can move. This moves following the patient walking. This gate, this frame can move following the patient movement. っていうやつがあって、それは例えばこれがココマのアンダーゴっていうこのムービングロボットですね。モーバイルロボットがサポーティング the weight compensation ですね。どっか違うでもいますか？
To offer offer intensive gait training in versatile life situations while ensuring the patient's safety means a big challenge for health professionals today. Here, Kokoma's Andago comes in. The Andago bridges the gap between treadmill-based gait training and free overground walking. Andago actively follows the patient and needs neither to be pulled nor pushed. It acts as the patient does without being confined necessarily to one room. With its dynamic body weight support, the Andago assists patients to walk naturally while providing continuous physiological afferent input. This allows patients to train with full hip extension and balance reactions.
Or you may see these two bars here. Two bars there. Two bars supporting. High two bar is necessary. When some people walk the level walking means almost constant to the same height as walking. But actually, or more precisely, the human's head moves up and down. And also the shoulder position is not so the same position, same height. So some the swinging, rolling, and also the up down is compensated by these two bars swing conditions. To keep the exact percentage of weight should be supported. So therefore the balancing condition should be checked, and how much support weight should be produced by each bar is also should be controlled more precisely. ということで、that is also a similar problem to this kind of sling technologies. これとかも this is also the same. This is not only the same position to support, but to the actually some length control and tension control should be realized to compensate exact weight ratio. Supporting ratio should be kept to, so thereforeそれどっかにこれにはないか。どっかに。ウェイトコンピューター、How to Person じゃないや。どっかね、ないか。いや。はい。さっきのちょっと続きを見ると。
To offer intensive gait training follows the patient and needs neither to be pulled nor pushed. It acts as the patient does without being confined necessarily to one room. With its dynamic body weight support, the Andago assists patients to walk naturally while providing continuous physiological afferent input. This allows patients to train with full hip extension and balance reactions. With Andago's adjustable fall limit, patients can train in a vertical range and even tackle advanced training tasks like step training or balance exercises. Patients are empowered to train without risk, which opens the possibility of efficient therapy group settings with limited supervision. Objective training documentation and out-of-the-box use settings with limited supervision. Being trained are empowered to train.
Not only the flat training, but also this kind of step or not unstable object stepping is also for rehabilitation. This kind of training is also necessary. So, but some weight compensation should be given. So therefore, the control is also important to detecting, estimating the patient condition, the stepping or some unstable object, but the weight should be supported, or the confirm the safety is also necessary. So therefore, some control technology should be applied.
Without risk, which opens the possibility of efficient therapy group settings with limited supervision. Objective training documentation and out-of-the-box usability ensure seamless integration into daily routines at the clinic. Okoma Sandago, one small step for the patients, one giant leap in their recovery.
はい、これがホコマってやつですね。いいですか？で、私たちが Our Laboratories approach is making this kind of robot、モバイルロボットを作りました。これは、まあ、トレーニングメソッドっていうのは、こういう、なんかサポートトゥールとかで、ワーキングとか、あとはゲームでもいいんですけど、これはゲームは、ステッピングアニマルテイルズゲームって言って、プロジェクター、the some screen on the ground. And this animal's tail is shown here, and some people want to step on the animal's tail. It looks like this. And also, this is a bomb. The bomb fuse is shown here, and to prevent the explosion, this fuse should be fuse fire should be disappeared. So therefore, by stepping, this fuse should be prevent explosion. And this step, the footprint is also shown on this screen. This is a target for this trainee's walking next target, next step's position. So it should be shown on the ground. This looks like this. And so therefore we developed this system. Firstly, the structure is foot detection is very important technology to realize this. The rehabilitation steps looks like this. Firstly, some tutor is teaching the trajectory. The tutor walk ahead of the mobile robot, and the mobile robot is track and record the tutor's steps. First step. And the trajectory is arranged. And then this is a training phase. Training phase is mobile robot is in front of the trainees. And the mobile robot give the trainees target of next step. And if the trainee is successfully put on that target step, target footprint, the mobile robot moves and then shows the next target of the footprint. Is this system. So by using the laser range scanner, some users' foot is detected. So from this measured point, this system estimating this user's footprint's center position and also the direction. For example, this is a trajectory. The tutor step looks like this. This is the teaching phase. The blue one is a tutor's footstep, and this point is a mobile robot's movement, following the tutor's movement. It stopped and moved, stopped and moved. Following this tutor's movement. Okay? And then the training phase. This is a patient trainee's first initial position, and this is a robot's initial position. The robot shows this target, and the patient can successfully step on this footprint. The robot moves another next position and shows the next target. This is repeated. This is shown here. Mobile robot is here, and this is tutor. Tutor shows. Tutor moves step by step, and then the robot records his trajectory. This is not the usual work because the processing time is not so short. So therefore, he walks step by step, and this robot records his steps one by one. Partly recorded. And then the training phase looks like this. Start して、ちょっとこのアルゴリズムは少し、アルゴリズム is little bit funny for to make the robot movement. But if the patient is successfully put on his leg, he put on his foot on this target mark. Not only position but also the direction is matched to this target. The robot moves the next position and shows the next target. っていうシステムです。これね。はい。というようなものを作りました。で、これは、to realize this.The important point is, as I said, the laser range scanner using and the laser range scanner as the detection point. From this, the user's step position orientation should be estimated. And if the patient is using some cane or some supporting tools, this system can distinguish other obstacles and from this footprint, shoes, patient shoes, because of using the estimation system of the footprint, footmark, shoes. This has become one paper. So if you can access, if you have interested in, you should access this, because this is an open access journal. You can download this paper later. これは this part is a lower pin ね。どこまでやりますか？ここまでやりました。OK。はい、じゃあ次はアッパーリムですか？じゃあアッパーリムですね。アッパーリムパート。Upper limb also, the stroke patient has paralyzed right leg or right arm or left arm. So to recover the usual function, normal function, firstly, range of motion exercise is important. Range of motion is it is paralyzed, so therefore it moves repeatedly and the movable area should be extended. Firstly. だから paralyzed, fixed. So therefore the movable area should be extended, increased. Okay? Firstly. To do this, the standing motion, standing, wiping motion or some wiping motion or sling therapy. By using this sling, the sling means the body arm self-weight is compensated by this sling, so therefore it can move easily. So therefore this kind of sling therapy, sling exercise is done. And then the next is also the strength training is necessary to make muscle stronger. So therefore this weight should be moved, should be up down. This slope can be changed, so therefore the workload can be adjusted. So therefore this workload weight training should be done. capacity of action of upper limb, power, coordination, and the range of motion training. Used to train upper limb motion coordination and okay. Thirdly, it can move the arbitrarily, roughly, even in the roughly, but coordination training is the next final part is coordination training. That means the hand, finger, hand function combined trainer とか、ハンドファンクショントレーニングボックスとかあるんだけど、まあトレーニングボックスは例えばhand-eye coordination, eye-hand coordination function because we watch some object and we have to reach it and pick it up. So the visual information and the arm movement function, motor function should be coordinated. If it is a moving object, we should catch it. So the eye visual sense and also the motor control should be coordinated. This one step is this is a toolbox. Toolbox is picking some pin and inserted in a hole. Inserted. Toolbox is many kind of tools is here. For example, keyhole and key is inserted. Or the そう例えばまあペンとキャップ、ペンシルキャップ、putting. This is also the coordination training. Hand operation and also the visual information. Coordination is necessary. So therefore, this kind of training should be done of the more precise operation. で、どんなロボットテクノロジー is developed? This is early 2000. This is これベテランズアソシエーションのパロアルト忘れちゃった PA I don't remember. But Stanford University is developed this robot for arm rehabilitation, reflection symmetrically, both arms is supported. And also this is Rehabilitation Institute of Chicago, the arm guide about this is also the early 2000. This robot, the exoskeleton type is used to the upper arm training. Okay? あとは MIT の MIT Manas っていうロボット is developed. Manas is only the plane movement, two-dimensional movement robot. But the two-dimensional movement, by using this two-dimensional movement, this kind of games is used to the rehabilitation. ちょっとどっか見てみますか。こんなもんかな。こうトゥーディメンショナルムーブメントのパラレルアームがあって、それでパラレルのムーブメントとこのパラレルのこのターゲット、ノーマルポジション、ターゲット、ノーマルポジションというとか、NEXT はなんか色で This button とかボタンプッシングゲーム。こんだけですか。もう一個こっちにいいですか。こっちの方がいいかな。
Our mission is to provide treatment, education, as well as research.
Well, we definitely wanted to bring in the greatest technology we could into the facility. We really want to vamp up our technology. We want to have great carryover with our patients. Specifically this machine, we know that we can get a ton more repetition that we can provide in the normal natural setting of the clinic.
We've acknowledged that the use of robotics is the way to really help these patients gain the largest yield in that shorter period of time.
You can get 400 reps in a 45-minute session. Allowing that, in a session with the robot being able to do that, that first of all was just like, that sounds amazing. I want to see this. I want to get more of it.
If they have a flaccid arm, or if they have a spastic arm, the tone imbalances, or if they're just weak, they're able to do so much more with the support of the arm while they're motivated to promote the range of motion.
It's good for that visual scanning, for coordination. Their overall function may be decent, but they need some endurance training, some problem-solving training. It's another tool. It's something different.
With the in-motion robotic arm, to show the patient this is you moving your arm, and when we're feeling like maybe there is an activation in those muscles, it's able to show that there is, and so it's motivating to them.
Research shows, especially with the TBI, the stroke is the form of the TBI and ABI, the most important thing is for the affected arm, affected side, is to be used.
The team
はいやというような話ですね。これがアーム、ハンド、リスト、リハビリテーション、今バイオニックという会社です。これは EU プロジェクトで EU プロジェクトでユナイテッドキングダムのリーディングユニバーシティでこういうスリングアームをスリングして3ディメンショナルムーブメントをこのアームでウェイトコンペンセーションしながらやりますよというやっぱりリハビリテーションロボット。ロボットメディエイテッドセラピー for stroke patient in virtual world makes exercising more enjoyable and effective と書いてますけど、そういうのですディベロップでこれはスイスの ETH のチューリッヒはこのエグゾスケルトンタイプロボットをアームイン1、アームイン2、アームイン3とか言ってこうまだ5とかプレゼントに This is the latest version is looks like this これ4を見ますかアームイン4VR ゲームになってるんですよとか言ったんでこれが to large scale モデルはいっていうようなやつをそれは今モデル4なんですけど今プレゼントにはもう少しlittle bit smarter ですそれと同じように、さっきのポコマスイッツァーランドのカンパニーが This kind of system is commercially available now アーメオパワーとかonly これはロボティックアーム is supporting and only spring mechanical spring is used like this こっちかなただのブームの、これがコンペンセーションオーバーヘッドスライディングsuspension system is looks like this いろんな more simpler type is also produced あとはこれはレオゴーっていうのはこれモトニカっていう会社ですけど This is basically the Israel company is a joystick type rehabilitation system is also here ジョイスティックタイプでもちろんこのロッドレンス can be adjustable So therefore, the 3D、3dimensional movement can be realized by this joystick. っていうようなシステムで、なんかゲームを使って、Rehabilitation will be done. これを見てみますか、元にカンパニームービーのロゴ。 これに
Learning
イントラクション
tools always work to help people who need
これですね。はい。
That vision is now a reality. Leveraging the very latest robotic technology, our groundbreaking rehabilitation solutions reinforce neuroplasticity and motor learning in patients suffering from neurological disorders or orthopedic injuries. Ryogo is an advanced robotic system for the rehabilitation of the upper extremities. Designed to facilitate functional movements in 3 dimensions using repetitive arm movements by an advanced, fully motorized robotic arm, Ryogo provides a unique range of operational modes that retrain a variety of neurological and orthopedic patients. Ryogo enhances patient engagement and motivation through a variety of interactive and stimulating games that imitate natural hand movements. Motorica's unique Elite Enhanced Learning Intelligence technology provides automatic diagnosis of the patient's current status, resulting in customized treatment and streamlining of the rehab process in order to speed recovery while achieving better results. Motorica
まあいいやということで、まあ、2-dimensional display is used for the game display ね。But also,この例えば VR system is also combined to this system。これはヒロモーションというジャーマニーモーションですけど、ディエゴっていうシステムはこのヘッドマウンテンディスプレイで VR でこれはスリングで、ウェイトコンペンセーションしているような、アームリハビリテーションシステムですけど、This system is VR as he is inside of the 3-dimensional VR system, the catching or some painting or some other operations by using this kind of game, 3-dimensional games, this he will be recovered. ですね。VR トレーニング、例えばスイミング、あ、切れてる。これはラウンド、ダメだ、切れてる。あ、ちょっと好きです。他にも、more simpler one は、こう 2-dimensional タイプのこういうシステムとか、2-dimensional タイプシステムとか、on this flat plane で 2-dimensional movement タイプとか、これリニアモーションタイプとか、いろんなシステムがあります。これは EU カンパニーで、これは上海の会社です。あとは、このハンドムーブメントだけじゃなくて、このリストムーブメント、リハビリテーション is also necessary。リストね。リストムーブメント。で、リストムーブメントで、one important product is by money track ってやつで、by money track っていうのは、ただこのリストムーブメント、リストのコントロール。ね、で、paralyze one and normally using movable one。で、if the normally using movable one is operating like looks like this, the paralyzed one is operated to look like this。これはシンメトリカルとかミラーモーションとかシンメトリカルモーションとか It can be trained ってやつですね。By money track これは very very effective for the patient's motor ability recovery ちょっと見ますかエピソードビデオレンジオブモーショントレーニングするからで、だからレンジオブモーションをしてアッパーワンとローワーワンを決めといてこのムーブメントのリピーテッドリでトレインto move smoothlyこれナンバーオブタイムズパッシブ書いてます 両方ともだからトレーニングについてはパッシブパッシブ or active active passive active you can change まあいいやはいというようなバイマニュートラップというのがありますでそれからフィンガーねこうフィンガーのタイプフィンガーオペレーションフィンガームーブメントトレーニングのロボットもありますのでこれもキロモーションがアマテアというやつです同じようにフィンガームーブメントについてはこれは香港の会社ですけどこれ、メカニカルリンクムーブメントのこういうフィンガームーブメントリハビリテーションのハンドオブコープってやつとかあるいはここにあるのはイタリーのイドロギュメンテッドっていうところのクロハーナシンフォニアとかいうロボットこれは、ここにワイヤーがやっぱりワイヤードリブンでエクステンションムーブメント is supported by this wire drive ってやつですねっていうのがありますニューロモーターリハビリテーションアッパーでそれからこういう細かな not only precise movement but the hand arm therapy でただ only this motion sensor IMU is inserted in this この tool でこれはムーブメントリハビリテーションとかこれのハンドムーブメントリハビリテーションとか例えばこのドライビングモーションリハビリテーションとかそういうこのハンドムーブメントリハビリテーションいろんなものにvarious tasks can be realized by detecting this IMU sensor is included in this device ですあとはなんかアタッチングトゥールですねハンドアームセラピー&エバリエーションデバイス in one sensor hand for all areas simple multiplied まあなんかペダゴってちゃったパブロっていうやつパブロっていうものが出していますフィルム見てますか
The journey of rehabilitation is often long, slow, and exhausting, both physically and mentally, for patients and therapists alike. This is particularly true with the often difficult task of selecting and applying the appropriate therapeutic tools and methods. Introducing Pablo, a modern wireless assessment and therapy device for the rehabilitation of patients with impaired motor functions that allows therapy for all phases of rehabilitation of the upper and lower extremity, as well as the trunk and head. The core components of the Pablo system are the Pablo hand sensor and the Pablo motion sensors. The hand sensor is a hand-arm therapy and assessment device all in one. It provides training for all gripping forms and traces the strength of the hand and its range of motion. The design makes it possible to measure and train a wide range of hand grips, finger pressure, and movement of the patient's arms using inertial measurement units. Pablo utilizes wireless charging and transmits data between its 3D motion sensors and a computer via Bluetooth, giving therapists access to detailed information regarding the patient's progress. Pablo's motion sensors allow for precise joint assessment unilaterally and bilaterally. Built-in games add an element of fun to a patient's rehab. Pablo's motion sensors can also be attached to a patient's lower body, allowing for strength building, body control, and functional exercises. A single Pablo set allows for the simultaneous treatment of up to 3 patients at once. Pablo's built-in games accommodate cognitive therapy for children and adults, both unilaterally and bilaterally. The multi-ball's new design supports pronation and supination training, as well as wrist extension and flexion training. Patient-based usage allows the therapist to tailor the therapy to the patient, while still measuring a high degree of movement in all axes. Pablo's mounting options and motion sensors combined with included games allows the therapist to provide entertaining therapy options in varying degrees of difficulty. Exact measurement of upper extremity joints makes it easier for therapists to detect and correct compensatory movements.
ね、だからただオンリーこのセンサーと this センサーのレラティブアングルだけね、こうつけたレラティブアングルだけみんな。でも this is useful for the rehabilitation of the measuring the recovery degree and so on。でこれがothers ワークで、これが our laboratories ワークで、アームリハビリテーションはプロジェクションシステムで、プロジェクター and the sensor system and computer these three by using these three parts the IDAT system 1, 2, 3 the final one is here the combination of projector and sensor and it directs the hand motion. It provides three games, the hack-and-maul game and balloon breaking game and the fish catching game. This is using the visual sense and the motor control. It is no fixture to the arm. It's only the patient's intended motion, not forced movement. 今ちょっと言ってるくさい。例えばハンマー叩いたときは using the hammer it looks like this ですね。これではじめにウェルカムスクリーンで、これは3 parameters is there. This is the duration time. Secondly is the degree of movement, 7 steps. And also the movement portion, 3 portion is simultaneously moved. And these 3 parameters is set and starts the game. ということで、これはハッカーモールゲイン。ただ、でも別に is very useful. The visual sense and the arm movement is measured. So therefore this is important. Secondly is a balloon breaking game. Balloon is here and it is watched and tracing the movement and break game ですね。それからもう一つは、フィッシュキャッチングと言いながらフィッシュをみんなこうしてんだ、叩いてない。これなんかリメイニングタイムとかナンバーオブオブジェクト、ヒット。で、finally, the number of mole total and the hitted number and the hitted ratio and balloon is hitted ratio とか fish hitted ratio should be shown here っていうようなやつでした。Why we prepared these 3 games? これはモールはランダムリーアピアで、バルーンはこのバーティカルムーブメント、バーティカリームーブメント、and the fish はホリゾンタリームーブメント。So therefore the different direction, different kind of movement, he has to track, he has to watch and estimate the movement. So therefore we prepare these 3 kinds of movement. And the important point is that for him, where it is hitted and how long it takes to appear after appearing this object and the hitted, all of the information can be recorded. So therefore the recovering result, not only the result screen but also the back data is also stored. So therefore the physician can, the medical staff can estimate the degree of recovery of this patient. And also we develop for the multiple users air hockey game like this. 12時3ですね。 エアホッケーゲームもなんかデュレーションタイムとかナンバーオブゴールトゥウィンとかスピードムーブメントオブザパックとかあるんだけど、まあ、3 parameters can be set。これはパックでなんかこうしますよとかいうゲーム作りましたっていう話とか、あと同じように、まあ、バーチャルピアノとかバーチャルシロコンとか作りました。ちょっとこれは、R1 student is summarize his work for his graduation. これマスターシーズ。
IDAT machine is aimed to help people in rehabilitation of the upper part body, and because there are no current systems that can respond to our requirement, so we need to develop the IDAT machine. IDAT-3 is now used in clinical tests in Japan, but the laser length scanner using in IDAT-3 is too expensive. We think the action is a solution, so we try to replace the laser length scanner by action. And then we get the IDAT2 Mark II, which is far cheaper than IDAT3. In this video, we will introduce visual keyboard and visual cellphone to show how IDAT2 Mark II is working. This is visual keyboard. To make it working, 3 algorithms is needed: hand and finger detection, touch and release detection, and mapping the touch point. By this, we can make musical keyboard playing with multi-finger touch, hand detection. From action, we can capture user real-time body movement from RGB camera and IR image sensor. And when combine two data together, we can know each pixel distance between object and action. And after compare with initial background image, we can extract complete hand shape and track user hand without any special marks or equipment. Then, we find contour of hand and can recognize user finger in real time. Touch detection. By using depth sensor in action, we can measure the length between object and sensor. And we create touch event when user finger is past the threshold, and if finger is released after touch, then it would be release event. Mapping the touch point. After knowing the hand and finger location and the touch event, we map them together by combining the detection results, so we can make the visual keyboard playing with by hand as using touch screen. This is visual cellphone. To make it working, 2 algorithms is needed: hand and tools distinction. We separate hand and tools by shape, size, and thickness of object. So we can make some button or some program work only by specifying knowledge, touch speed detection. By calculating time at high T1 and T2, we can know knowledge touching speed and make the different reaction based on it. Like higher speed means higher sound volume.
ストレンジじゃなくてスピードがハイスピード makes louder voice, louder sound っていうのをやりました。これは one student's work more than 5 years ago ですね。彼の最後のファイナルプレゼンテーションの話です。ということで、さっきの、リハビリテーションのやつはイメージプロジェクションデスクトップアームトレーナーっていうのは、This is a journal paper. So if you are interested, please read it. And the projection technology is now become fashionable, and then this kind of large scale visual projection technology is used. And also this kind of commercially available rehabilitation system is also available from the UK. Yes. Hi. Today's content is look like this. It's okay.